All right, engineers, let's dive into the fascinating world of hydrogen engines. Today, I'm giving you a simplified overview of creating a hydrogen internal combustion engine, or HICE. This isn't just for the gearheads, but for anyone curious about the future of sustainable engineering. First things first, understanding the basics. Hydrogen engines come in two primary flavors: the hydrogen internal combustion engine, HICE, and the hydrogen fuel cell engine. While the former burns hydrogen directly in a modified traditional engine, the latter uses hydrogen to create electricity that powers an electric motor. For this guide, we'll focus on the HICE. Next up, choosing the type of hydrogen engine. Since we're sticking with the HICE, let's move on to gathering your materials and tools. You'll need an engine block, a fuel delivery system, an ignition system, a cooling system, hydrogen storage, and various sensors and controls. Now, modifying the engine block. Hydrogen burns hotter and faster than gasoline, so you'll need to reinforce the block. Use materials like stainless steel or titanium for pistons and valves. Adjust the compression ratio to prevent pre-ignition, since hydrogen has unique combustion properties. Designing the fuel delivery system comes next. Install hydrogen-specific injectors, use stainless steel fuel lines to avoid embrittlement, and ensure your regulators and filters maintain the proper pressure and purity of hydrogen. For the ignition system, high-energy spark plugs and robust ignition coils are crucial. Hydrogen ignition requires reliable and powerful sparks. Enhanced cooling is essential because hydrogen combustion generates more heat. Upgrade your radiators, pumps, and coolant to handle the increased thermal load. Hydrogen storage and safety are paramount. Use high-pressure hydrogen tanks that meet safety standards, install pressure relief valves, and integrate hydrogen sensors to detect any leaks. The engine control unit, or ECU, needs precise programming to manage hydrogen injection timing, ignition timing, and the air-fuel ratio. Connect all necessary sensors to the ECU for real-time monitoring. Now for testing and tuning. Use a dynamometer to measure performance and make adjustments. Fine-tune the ECU settings for optimal efficiency and conduct thorough safety checks for leaks and system integrity. Finally, installation and integration. Fit the engine into your vehicle and ensure compatibility with existing systems like the transmission and exhaust. Perform comprehensive checks on the entire system, verifying fuel delivery, ignition, cooling, and safety systems. Remember, hydrogen is highly flammable and requires careful handling. Follow all safety guidelines, ensure proper ventilation, and only qualified personnel should work on these systems. Building a hydrogen engine is complex and demands expertise in engineering and strict adherence to safety protocols. Collaboration with industry experts and access to advanced facilities are crucial for successful and safe implementation. That's a wrap on our simplified overview. Stay curious and keep pushing the boundaries of engineering. Thanks for tuning in.